Hey guys, so welcome back to Watch Your Day Struggle. And today's video is going to be interesting because it is about the actual tech stack and the cloud architecture, not cloud architecture, but the system design of Reach, the SaaS that I'm trying to build. So in the last video, we actually discussed about how the whole system works and what the whole thing is. Like not how the whole system works, but what Reach exactly is. So today we're going to get a deeper dive into the whole system and how the whole thing is architected and what are the different services and what are the different things that I'm using. So let's move to my browser. Yeah. So this is very simple diagram. I mean, it is a diagram. Yeah, a very simple diagram which explains the whole architecture of how this thing works. So yeah, you know what? Before I actually get into the whole tech stack and whole architecture, I should probably give you guys uh, not give you guys like tell you guys about the ideologies that I have in mind and using what ideologies I actually use to design the whole system. So performance was obviously one of the goals, but over the past few years of working as a software engineer, I've realized I'm great at you know writing software. So like if there's a use case, I can probably make a software solution which will be able to um, you know make it work. So like let's say just send mails using your Gmail account. So use Google OAuth and use all the different Google APIs to send mails uh, using someone else's email. So let's say you go to my website and you use Google authentication and log into it, and then if you click on a send button, it'll send a mail to someone, and that will show up as sent by you. So yeah, so I was able to build that like 2.5 years ago in my second year of college. But even back then and even now, back then a lot and now till some extent, I am able to write subpar softwares, like things that perform okay but are not really resilient, or uh, yeah, resiliency is the word I'm looking for. So like not production grade. So I could write for that mail thing. It would work for one how to explain this, one user flow. So like I would make these solutions just enough to work for that one user flow or for that two or three use cases. It would have a bunch of features and I would have a lot of things to tell that I built this. But when it comes to show, even I didn't know how many of these things would work or not. So with Reach, I want it to be different. So what I call is called ROP. So my main focus with Reach is something I call define as ROP, which is resiliency, observability, and performance. So initially, when I started this project, the ideology behind all the technical decisions was just performance. But obviously, there's no user performance. There's no point of getting responses in like within a few milliseconds if you're not even sure if you'll get the response or not. Like getting a response 1 out of 10 times within few milliseconds is not better than getting the response every time within, let's say, tens of milliseconds. So yeah, resiliency and observability is as important as performance, and that's been a theme with this system design and with stuff that I'm trying to build here. So yeah, let's dive deep into that. Okay, so yeah, one more thing. I really wanted to learn a lot of stuff with this project. So things like microservices and proxies and caching and SQL and all these things and gRPC. So this might seem like an over-engineered solution, but you have to remember a lot of decisions here are also made on the fact this is something cool that I want to learn, right? So yeah, let's move on then. Okay, so like I said, I wanted to learn proxies and microservices and gRPC and Postgres. So in hindsight, you can directly see there is an auth proxy. So this is my web app. This is the main portal, and it's written in Remix, and it uses REST over HTTP2, preferably HTTP2. Uh, I haven't really figured this part out yet, but preferably with HTTP2, and talks to an authentication proxy which is written in Go. Uh, Gin to be more exact, the HTTP framework Gin. It is very performant, and on my local setup, I'm able to get responses in sub 10 milliseconds, even microseconds in some cases when the cache hits. And otherwise, even in my like development setup that is hosted on Railway, I get double digit microsecond responses, which is pretty great. So that talks to this auth proxy, and this auth proxy uses gRPC to talk to all of these different microservices. So all these different microservices are actually the features. So like I said in one of my last videos when I showed what remix or what reach was, huge thing with reach was toggable features. So you might end up using reach only for Kanban and nothing else, and that should be possible to do. And that's why I built all of these different features as different microservices, right? So Kanban is one service, page is one service, um, mail would be one service, analytics would be one service, and so on and so forth. So all these talk using gRPC. Now, someone could argue, why are you using gRPC? So let's get a little bit into that. Sorry. Yeah. gRPC versus REST. Can't really exactly call it REST because gRPC is also based on top of REST. I'll show you some code which will prove this. But let's say, I don't know, APIs. So multiple reasons. First and foremost would be, most important one would be I want to learn it. Okay. I know it sounds a very like a very dumb reason to use it, especially when I'm talking about performance and ROP and the whole ideology of ROP that I built. But yeah, like learning was very important. Second, if we talk about performance, then gRPC is better. I'll tell you how. So okay, let's talk about JSON for this. The multiple reasons why gRPC is faster. One would be HTTP2. So we'll type. Okay, let's start with HTTP2 then. First reason would be HTTP2. Default. So if I'm not wrong, I might be wrong here, but gRPC by default uses HTTP2, right? So in that case, how is HTTP2 better? In terms of performance, obviously. So in terms of like speed and stuff. So let's take another step and let's first understand how HTTP2 actually works. Let's just first talk about how HTTP works and how TCP itself works. So HTTP is based on top of TCP, right? So let's say we have a client. Okay. Yeah, and we have our server here. Okay. Now let's say we are trying to send our first request out, right? It's just a simple GET request. Okay. So for this request to happen, what the server and client need to do first is, the client needs to send one request. Mind you, this is a TCP request and this would be a sync request. So why do we need this sync request? So the way TCP works is TCP on both ends uses something called buffers. And those buffers have something called segments inside of them, right? And these buffers need to be synced up on both sides before the request can actually happen. I don't want to dive very deep into how TCP works. You can read a blog about it. I'll probably put something interesting in the description. So yeah, so first happens a sync request. Then the server tells the client, okay, I acknowledge your sync, and now here is my sync request, right? So here is the condition of let's say my buffers or something like that. So here is what you need to sync up. Then the client would actually send another acknowledge request telling, okay, yep, I got it. So we are now both in sync now. And only after this, sorry, only after this is done, the actual get request goes through. Right? So this is how TCP works by default, or not actually TCP. Matlab, yeah, this whole thing is called a TCP handshake, right? And let's mark it out. So let's use this. This little thing here is called a TCP handshake. Right? So HTTP 2 by default needs a TCP handshake to work. Okay. Now HTTP 2, right? HTTP, the first version, the H1, needs this TCP handshake to happen for every request. But the biggest feature that comes with HTTP 2 is called batching. Okay. So let's say if there are 10 requests, let's go here. 10 recs in HTTP. So we're just gonna call it H1. H1 almost equal uh, is almost equal to 10 into 4 requests, right? Because there are gonna be 3 requests for the handshake. Let's just call it n requests. N requests in HTTP 2 actually ends up meaning n star 4 requests, which is not that great. On a slow internet connection, it actually increases the speed, by a lot. Now, if you go to HTTP 2, so let's say, again, let's take a similar example. Actually, I can't really draw an illustration for it, so I'll just explain it. This HTTP 2 uses something called batching, okay? So let's start writing it here. H2 uses batching, okay? That implies, or that means that for every request that is sent to the server, we do not need to do a TCP handshake. Let's assume, you know what? Let's assume a batch size of, let's say, 10. So what happens now is the number of requests that actually go, let's say it's called the batch size is B, okay? So for n requests in H2, we actually need to send 3 times n mod B plus n requests. Okay. So now if we start putting it values in this, if we take actually so if we try to put in values in this, let me just draw a straight line as a divider. Okay. Let's take n equal to 10. That implies, actually let's take n equal to 15. That implies 15 4 are 60 requests. Okay. And then in this case, let's take n equal to again 15, and let's take a batch size of 10. Okay. In that case, what it actually ends up doing is okay, so the mod would be actually my formula is kind of incorrect. I thought of it 15, it needs to be 2 n more. So if it ends up being 20, it again needs to be 2. 20 mod 10 is going to be 0. Yeah, this needs to be divide, and we need to do a seal of this. Ah, fuck. So seal of n divided by b. Okay. Yeah, this makes much more sense. So again, like if we go into this example, n divided by b would be equal to not n divided by b, n divided by b. So in our case, n by b would end up being 1.5, and if we take a seal of n by b, we get 2. So now if we put this in our value, then it ends up becoming 6 plus 15, which ends up being only 21 requests. Okay, how does this work? For the batch of first 10 requests, it will send 3. For the batch of first 10 requests, it'll do one handshake, which is like 3 requests. So that ends up being 13. So 13 on one side, 13 requests for first batch, and then for the rest of 5, it'll need another 3 requests, and then plus 5, and it ends up becoming 8, and that should be equal to 21. So this is how this part, the final part, was just verification of my formula because I just created it on the go. But yeah, so now you can see how H2 is really, really fast. Let me just cover this in one box. So this is one reason. Now we'll talk about another reason, because there are 2 reasons why performance-wise it is better. That may be the bad place. Okay, let me just move this. Just move this whole thing. Let's get this down here. Let's move this here. Yep. The second reason why gRPC is great is protobufs. Okay. Now, what are protobufs? Protobufs is a way of transferring data. Okay. So before I explain what protobufs are, let me just tell you what the problem is. So protobuf is a replacement for JSON. It's a way of serializing data so that you can send them over a network. So we all know JSON is a standard for sending data over the network. But let's try to understand what's the problem with JSON. Let's say, you know what? I want a JSON header. I want it online. It online. Yeah. Please tell me it has autocomplete. I really want those indentation and everything done for me. Please work. Please work. Excuse me, internet. I have internet. This is bad. Come on. Yep, perfect. So let's say we have, the data that's been sent over the network is something like a user. Okay, so we have name, then let's say Irish, and then we have age, let's say 21, right? This is pretty normal data that someone should would send over, network, right? So when we have something like this, it's very simple. It can be serialized, and it's pretty normal. But what happens when we have data in form array? I did that, yeah, in form of arrays. So let's say I have a array called users, and then inside it, the first object I have is this, then I have this, then I have this, right? How do I reformat this thing? JSON, perfect. Yeah. So now the problem with this is, let's just change these names just for the sake of it. So John, so okay. Now here's the thing. Let me copy it and move it there. It'll be what? Yeah. Mm, perfect. So here's the thing. In these two JSONs, I sent around, so in this case, all four of these values, like both the key and pair, were important because I had just one, right? Like if I just send you name and array, like aration 21, you wouldn't understand that the system wouldn't understand that's a name and a name and an age. But in this case, just for the first object, name and age, like name and age makes sense. But after that, we know that it's in the same format, and there's always going to be name as the first one and age the second one. So this is actually a lot of extra keys or extra data that is being sent over the network and is getting wasted. So in our case, it's actually not a lot. So we actually have like 1, 2, 3, 4, 5, 6 pieces of useful information, but along with that, we also get 4 pieces of information that is just waste. Because I'll tell you how it's waste. Because let's say if we had something like a table, so in that case I would have, so if I were to send data somewhat like this in form of a table, all I'd need is name on the top, age, um, whatever. You get the gist of it, right? Like I can just do this. And in that case, I have no useless data. All of this data is important, right? And if I convert it into some kind of a string, like even if I can figure out a way to send the data in this format, that there's a delimiter and all that stuff. Let's just assume something happens with Python and I'm able to send data like this. There's obviously much less data traveling over the wire, which indeed means fast, right? Because there's less things to send and like it just gets, it's very obviously less data means less transfer time and blah blah blah, right? So that's how protobufs are much better. So this is what a protobuf format looks like. So I can show some code. Let me go in here and uh, check. There should be definition of all of this. No, this is the, so I think definition is your blah 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 blah. Nope, 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 nope. Mm, mm. Yeah, okay. First thing. So when I said that gRPC is actually based on top of REST, you can see it creates routes like these. Something similar to route, and it has handlers attached to it, method name and handlers attached to it. I can actually show you proper routes. I'd seen it somewhere. See, okay. This is what I was looking for. This is how the raw description, or like how the actual protobufs are found like. So this is all binary encoded data, and it sends it like a table. Okay, I'm actually very bad at explaining this, but yeah, basically, protobufs actually end up creating tables. I am really sorry I wasn't able to show that very well here. I'm gonna do one more try. I am gonna try this one. Maybe here I can see this. Oh, by the way, this is fine. This is, yeah, see, like when I said it's like on rest, so it creates proper routes like this, and then it assigns handlers. So that is how the rest part actually comes into play. And please tell me I can show, can find the tables being formed. Okay, I don't remember where I'd seen it, but I was able to, find basically a place where these kind of table are formed, right? So this is how data is sent over, and that's how we save a lot of storage. Now, one more important thing here is there's obviously less data being transferred, but another problem with JSON is JSON serializing, deserializing, or marshalling and marshalling is very slow process. It's a very slow process, and you can look it up anywhere you want. You'd find out that it's very slow, and that's why protobufs, even though it's sending it in form of tables, it is binary encoded. So the communication between all of my microservices is hyper fast, and even I don't know if I have screenshots, but even after I send requests over you know network, so I get my from my Remix app the first so from my Remix app the first request is HTTP2 going here. This is doing some for processing, so it's validating the session, it's validating if the person has permissions or not, and then it's routing it down to my services. They are doing their processing, talking to the database, talking to the database and processing them data, sending it back, and the whole process is still 2-digit milliseconds. Even like on local, it's 2 digits or 1 digit, but over a network, I'm getting close to 100, which is 100 milliseconds, which is very acceptable. Like in the lower 100, sometimes mostly it's two digits, but lower 100 is also fine, right? Like let's try to see the logs. Mm, let me find. Why can't I find any requests? Yeah, so I have 89 millisecond response, and this is like a session create was 300, which is okay, but a session, verify, a session validation response was just 89 milliseconds. DB fetch or DB read was 98 milliseconds, and so on and so forth. These are, I guess, pretty good response, right? So yeah, even over the wire, I'm getting good results because of this. So I'm pretty happy. Let's go ahead and mark this as a reason, right? This is the reason why I actually ended up using gRPC for communication between my microservices. It's not really like it's kind of a norm, but it's not really required. Like even where I work, like in Twilio, a lot of our services communicate over either Kafka streams or they're like Kafka stream apps, and they're all consumers and the producers, the microservices, or over normal REST, which is fine. But since this communication is very often and there's a proper proxy, I thought it'd be fine. And like obviously I wanted to learn, and it's pretty fast. gRPC is pretty fast. So, and yeah, one very important thing is gRPC ends up giving me end-to-end type safety, which is very difficult to achieve with REST. Like I mean with normal HTTP servers, right? So that is great. Mm, yeah. Okay. Next is why Postgres. To be very honest, Postgres is just amazing, and my SQL wasn't that great. I'm slowly and steadily getting better at it. So another reason for SQL was learning. Another reason for Postgres for was learning SQL. And to be honest, Postgres is performant enough, reliable enough, and with the right tools, it's observable enough. And for all the kind of things that I'm doing, Postgres should be all I need. I really don't see a use case where I might need a database better than Postgres. It can handle all of my needs. So yeah, that's why Postgres. Moving forward, all of these are pretty simple things. I have my cache over my proxy. So this might be a question like why do I only have one cache and that too only over my proxy and not over my services? Since as of right now, my plan of hosting these is hosting all the services in the same region. And no matter from where you send requests, be it US or be it India or be it Antarctica for that matter, the request will end up going to the same service, the same server. It'll go to the same auth proxy and it'll go to the same server, at least for now. And in that case, a regional or like a cache over all of the different, services did not really make sense because just because if my auth proxy can already serve the request from its cache, it doesn't need to send it forward to let's say one of the service microservices. Now, why do I put in the regional part in it? That's because if let's say I have three different regions, right, and or let's say I have five different regions for the auth proxy and three different regions for the services, because that makes much more sense. Uh, Auth proxy would be getting tens if auth proxy gets hundred requests per second. Out of those 100, on Kanban would probably only get 30% and like 30 requests, but page might end up getting 50 requests, whereas mail might end up getting 5 requests, and so on and so forth. So the traffic over all the different services, all the different microservices is not consistent, but the traffic to auth proxy is always is not consistent. Like it's like across all of the different services, the traffic might not be equal. Some might get more, some might get less. But for the auth, but it would always be a summation for the auth proxy, right? So if I have five different auth proxies to handle that load, which kind of serves it forward to the three different like three different regions of the services, I would need cache over all the services because let's say auth proxy 1, which is in US 1, and auth proxy 3, which is in India, are both connecting to the Kanban server, which is in Singapore. So there might be some request that came from the US, it reached the service, and it went back to the US. So it was cached by the auth proxy in the US, right? But it wasn't cached by the auth proxy in India. And in that case, if I had caching over all the microservices, it would make sense, because even the request from India uh, to the auth proxy fails the cache hit, but when it reaches the singular server in Singapore, it actually has the cache. It actually has the request processed in the last 5 minutes or 10 minutes, so it's still in the cache, right? But for my setup where I just have one, region where all of this is hosted, it's fine. Okay, moving forward. Next page server. So next page server is like a very simple service. Is Next.js SSG site generator, which will how do I explain this? Yeah, which basically is the renderer for all the different pages and all the different links and stuff that show up. So it's a very simple site generator, and I have a revalidate function on top of it, which I just push every time I make some changes in the you know in the system. Like every time someone on their account makes a change to the next page, I just hit the revalidate endpoint, and that just builds all the pages again. Then the landing page uses uses a mail service. Like, so if I go to the landing page, there is a small box here, and this ends up sending data to my database. Yeah, so I have a mail list table which actually ends up storing all the data, all the emails, and then I use a service called Resend, by the way, which is an amazing service called Resend to send mails. And yeah, I just send welcome mails. So it's a mail that says hi XYZ, thank you for supporting and all the kind of stuff. Very basic mailing. What one thing I need to add here is this is also there. I added this recently. I'm trying to add what I'm trying to add email verification, and there's a small issue with the actually I would like to move this here. That's fine. You can come here. You can just go down like this, this, this. Then you can touch back here as usual. This went a little too up, so I can just move it down a little bit, like here. Yeah, and you can calm down a little. Yeah, and you can look a little aesthetically pleasing and go back here. And yeah, okay. Yeah, so Resend is an amazing service that sends mails. That's great. Now the interesting part of the system design is actually the cloud storage part. So I'm using, unlike the general choice for file storage S3, I'm using R2, which is a Cloudflare bucket storage. I'm using that because it's cheaper, and that's all. And for some reason, I believe setting up a CDN over Cloudflare would be easier than setting up a CDN over S3. Even though I'm pretty sure I'll get much more guides for S3, so let's see. Anyways, so the Remix app, that's my primary app, would talk to R2 in two ways. One would be REST HTTP2 for the put requests. Actually, no. One would be normal REST requests for the put requests, for put, post, delete, all those kind of actions that, except get. So let me just rephrase. It's right, not a get. Anything that is not get will actually route through this. And how does it directly talk to R2? Because I have a service that would return a put URL or a delete URL, and my app would just send a request to R2 to do that. But for all the get requests, I'll have a CDN layer on top of it, right? Pretty normal stuff. The interesting part is where data duplication comes in. So the way I'm planning to handle this is having a Kafka, you know, like a Kafka queue or a RabbitMQ queue or some kind of messaging queue. So every time a new file is uploaded or deleted or any kind of stuff that happens here would just send a message or like produce a message onto the Kafka queue or any kind of queue, and then I'll have a relatively smaller lambda, like a lambda that will scale much less than what my actual service would scale to, which would keep consuming those messages and keep creating backups on AWS Glacier, right? So that way I have data duplication as well. And what I would also like to achieve is, if all of my R2 data is in US1, I'd like to keep my Glacier in in the APAC region, so probably in Mumbai or Singapore or something like that, so that I get proper data duplication, right? Yeah, that's mostly it. I actually have written a blog the whole about my whole you know tech stack. So let me just check this out if I missed something. I'm pretty sure I didn't. And if you want to get a deep dive into why I chose all the different things, like why I choose Remix, I prefer the pure MPA Remix like experience. So I like how multi-page apps used to work and how MPA works. I love the fact that it uses stable and reliable web APIs. So it's not trying to reinvent the wheel with anything. It's very much focused on primitive web standards, which Next is pushing towards now, but then Remix was there from day one. And why microservices, why using a proxy, and all that kind of stuff has been answered here. I'm just trying to see if I missed something. Not really. And yeah, I mean, if there are some fronted folks watching, things that I'm using on fronted is Chachi and UI, which I'm pretty sure at this point everyone knows. uh, Tailwind because it comes with Chachi, I'm using GitHub. Obviously, I have SCSS, and I'm using something very cool called Mantine. So Mantine is like Sachian, right? But it also has a few extra helper things. So okay, this is a new page. That is great. Still not supporting remix. Yeah, nice. Template here. Blah, blah, blah. Sorry. Yeah, but anyways, yeah, so they have a bunch of extra stuff as well. So they have Mantine hooks, which is a bunch of UI and state management hooks, which are really, really great. And I love them. I have this out of for Mantine, out of all the things I could install, I am definitely using the hooks because it gives me a lot of things. Like if I want to try to show you guys, there are cool things like use click outside, use color scheme, use element size. All these things are very trivial but end up becoming very difficult to set up, and especially when you're trying to generalize it. It's very easy to use you to write all of these things when you want to use it in just one component or just one page, but then when you try to generalize it, it gets very difficult. And they have state management stuff, they have utilities, the clipboards and stuff, use OS, there's lifecycle. That's all amazing. That just I just saw something, use local storage. Does it give me a reactive thing? Holy shit, I want this. Yeah, I am gonna start using this as well for the theme switcher and for all of my yeah, basic things. Cool. So yeah, this was basically about my tech stack and my ideologies behind the tech stack that I'm using. So if you have any questions, you can hit me up in the comments. If you want a deeper dive, you can read my blog over at blog.ireshsharma.com. And if you would like to contribute to this SaaS that I'm trying to build, you can go to github.com/ireshsharma/reach. All of these links would be in the description. Thank you for watching. Hola. Peace.